of x equal to f of a. This is the definition of continuity of f of x at x equal to. If the functions are same on left and right, we use this limit x tends to a, f of x equal to f of a. The first definition. Second definition, if on the left and right, if there are two different functions like f1x and f2x, especially for split functions, we use this method. If two different functions are there on the left and right, we have to split that limit x tends to a f of x into left hand limit and right hand limit. Like this, limit x tends to a minus f of x. It must be equal to limit x tends to a plus f of x equal to f of a. LHL is equal to RHL equal to f of a. Then we can write the function is continuous at x equal to a. Is that clear? The two definitions. First is limit x tends to a, f of x equal to f of a. Second definition, if there are two different functions on left and right, we use this LHL equal to RHL equal to f of a. So this is a direct question. On the left and right of f of x, there is only a single function. So we use the first definition. Limit x tends to 1, f of x is found. Normally we do direct substitution. If direct substitution fails, we do the alternate method to evaluate the limit. Here it is direct substitution. We got 2 plus 3, that is 5. F of 1 is also 2 into 1 plus 3. Both are equal, so it is continuous. These types are important question. X not equal to 0 means on the left of 0 and to the right of 0, the function values are the same. So here also we use the first definition. That is limit x tends to a f of x. Here it is limit x tends to 0, f of x must be equal to f of 0. Limit x tends to 0, f of x is limit x tends to 0, sin x by x plus cos x. So that comes like this, limit x tends to 0, sin x by x plus limit x tends to 0, cos x. So 1 plus cos 0, it is 1 plus 1, that is 2. So the left hand limit is 2. F of 0 is also 2. Both are equal. Therefore, f of x is continuous at x equal to 0. Is it clear, children, this question? That limit is sin x by x, limit is 1. And this is also a question, but on the left and right, the functions are different. When it is different, we use that second definition. Left hand limit must be equal to right hand limit equal to f of a. F of a is 5. So this type of split functions, we use the second definition. Left hand limit we found. Limit x tends to 5 minus f of x. So that comes like this. Limit x tends to 5 minus kx plus 1. That is k into 5 plus 1. It is a 5k plus 1. Left hand limit is 5k plus 1. Right hand limit is limit x tends to 5 plus f of x. That is equal to 10. So 5k plus 1 equal to 10, or 5k is equal to 9, k is equal to 9 by 5. So this is the value, k is equal to 9 by 5. Next is also similar question. On the left and right, two different function. So the second definition is applied. Here we got two equations as a result of this application, and both are equated. And then we have to solve these two by elimination method. And here we start the questions with the different forms. Direct application that doesn't work in this type of question. So please read this. Root of 5x plus 2 minus root of 4x plus 4 by x minus 2. X not equal to 2 means on the left and right, it is the same function. X is not equal to 2. So we have to use the first definition. That is limit x tends to 2 f of x equal to f of 2. It is given as this function is continuous. So limit x tends to 2 f of x is limit x tends to 2 root of 5x plus 2 minus root of 4x plus 4 by x minus 2. What happens there? When we substitute x as 2, it becomes 0 by 0. Yes, are you following, children?
Yes, sir.
Yes, sir.
0 by 0, it is not defined. So when it is not defined, we have to search for alternate methods. Here the alternate method for root questions, we multiply by the conjugate. Here root is in the numerator. So we have to multiply by the conjugate of the numerator on both numerator and denominator. Then numerator is a minus b into a plus b form. That is a square minus b square. And denominator is a multiplication. So from numerator, we get x minus 2 as the result of simplification. Then x minus 2 we can cut. In the remaining part, we substitute x equal to 2. So we get 1 by root of 5 into 2 plus 2. 1 by root of 5 into 2 plus 2. So the answer is 1 by root 12 plus root 12 or 1 by 4 root 3. F of 2 is also the same, k. So k is equal to 1 by 4 root 3. This is the calculation. As I told you in the beginning, since I have to explain almost all the concepts in a quick review, so I will scroll it up like this and explain. In between, if there is any doubt, you have to ask. At the same time, those who have doubt in this, you can ask me the record later and you will complete. Like this, on left-hand side and right-hand side, if it is the same function, x not equal to 2 means on the left of 2 and right of 2, these are the same function. We apply this first definition. Limit x tends to 2, f of x is f of 2. Those who join late, first definition all I explained in the beginning. Next, this one. This is a clear split function. X less than 0. That means on the left of 0, the first expression equal to 0. Then on the right of 0, the the third expression. So here we have to use that second definition. Second definition, we have to find the left-hand limit, then right-hand limit, then we equate it to f of 0. Look at the left-hand limit. Left-hand limit is limit x tends to 0 minus. We copied that left-hand expression, sine a plus 1 into x plus sine x by x. Since it is continuous, all these are equal. So that we can break into two parts. And we know the limit. Limit theta tends to 0, sine of an angle, theta by the same angle is 1. Now to get the same angle, we have to multiply by a plus 1 on both numerator and denominator. Then we get a plus 1 into x. Then that limit is 1. A plus 1 is taken outside. Like this, a plus 1 is taken outside. And then we have simplified it to get the answer. A plus 1 into 1 plus 1, that is a plus 2. This is the left-hand limit. Is it clear? Yes, all of you understood that left-hand limit. Any doubt? Then right-hand limit. Right-hand limit, there is a root expression. Root of x plus bx square minus root x by bx raised to 3 by 2. So I multiplied this with the conjugate of the numerator. Then numerator is a minus b into a plus b, a square minus b square. X plus bx square minus x minus x will go. So this is bx square by bx raised to 3 by 2. B is cancelled. B is also cancelled there. And then root x by root of x into 1 plus bx plus root x. And then we got the answer like this. Root x by root x into 1 plus bx. So that root x is taken outside from the denominator. X by x raised to 3 by 2 calculation I have done in the rougher space, that we get root x. And then we could cancel out that root x. Then in the remaining part, we substitute x equal to 0. So we get 1 by 2. So this is the right-hand limit. Then we equate LHL equal to RHL equal to f of 0. So then we get a plus 2 is equal to 1 by 2, a is minus 3 by 2, c is 1 by 2. But we cannot get b from here, b from here, but b is in the denominator of one of the expression in the question. So denominator, since b is in the denominator, it can't be 0. So we write b is r minus set to 0. So this is like a 3-marker or 5-marker type question. Is that clear?
Yes, sir.
Next. This one is another question. Here also, on the left and right, it is these are two different functions. So we have to apply the second definition. LHL equal to RHL equal to f of 0. Here it is continuous at 0. LHL, when we substitute direct, it is 0 by 0. So we apply that substitution. In trigonometry, in integrals and all, we have done this one. 1 minus cos 2a is 2 sine square a. That substitution is done here. 1 minus cos 4x is 2 sine square 2x. So hope you all understood that substitution. 1 minus cos 4x is 2 sine square 2x. It is 2 sine square 2x. Then we get 2 sine square 2x upon x square. That square can be taken outside the bracket, and 2 is also taken outside. So 2 into limit x tends to 0, sine 2x by x. But sine theta by theta is 1. So to get that one, we multiplied by 2 and divide by 2, sine 2x by 2x. So it comes, the 2 square is taken outside. The remaining limit is 1. So 2 into 4 into 1 square, it is 8. Is that clear, that left-hand limit? 1 minus cos 4x is 2 sine square 2x. Okay. Then right-hand limit is root expression. Root expression multiply with the conjugate. Here, conjugate of the denominator is multiplied. And then we could simplify it, and we got 8. Then we have to equate. So we get a is equal to. Next is also a similar question with the root expression. So these questions are of the same type. All of you understood this type of questions. Any doubt, children? Direct and indirect questions of continuity. Next, another important concept is continuity and differentiability. In this topic, continuity and differentiability. So that type of questions are here. This type of discuss the continuity of modulus functions. If you get, it is continuous at all points, but this will not be differentiable at the point where the expression inside the modulus equal to 0. That is, it is not differentiable at x equal to 1 and x equal to 2. So this type of question, we have to break the modulus. Each modulus you will break. Modulus x is negative x if x is less than 0, and positive x if x is greater than or equal to 0. Using that, we have to break that modulus, and then we will combine this. Okay, like this we have to combine, and then we get the combined form as the function. Then we have to check the continuity. Discuss the continuity means all 5 cases we have to check. Continuity from minus infinity to 1 at x equal to 1, then 1 to 2 at x equal to 2, then 2 to infinity. Like this, all cases, if it is continuous, it will be a continuous function. Now this topic is a very, very important topic, differentiability. A function f of x is differentiable at x equal to a, mean its left-hand derivative, LHD, at x equal to a must be equal to RHD, right-hand derivative at x equal to a. This is the definition of differentiability. Left-hand derivative must be equal to the right-hand derivative. Now, left-hand derivative we calculate like this. You can see the arrow diagram. I have marked the a, its image as f of a, and just before a minus h, its image is f of a minus h. After that one, a plus h, its image is f of a plus h. Left-hand derivative means from the left we subtract. That is, f of delta y by delta x is the formula for derivative. So limit h tends to 0, f of a minus h minus f of a. So the y is subtracted, delta y. from the left, f of a minus h minus f of a by a minus h minus a, that comes minus h. This is the left-hand derivative formula. So everyone should study this, by heart this well. Left-hand derivative at x equal to a is limit x tends to 0, f of a minus h minus f of a by minus h. Same way, right-hand derivative at x equal to a is limit h tends to 0. From the right, we subtract f of a plus h minus f of a by a plus h minus a, that is h. These are the two important definitions of left-hand derivative and right-hand derivative. Is it clear? All of you understood? So a function is differentiable means it should be, these two must be equal. Then this note is also important. If a function is differentiable at x equal to a, then it is continuous also at x equal to a. All differentiable functions are continuous, but the converse need not be true. All continuous functions need not be differentiable. And the next concept will come in MCQs. Inside the modulus, if there is an expression, it is continuous everywhere, but it is not differentiable at the point where the expression inside the modulus equated to 0. So which means it is not differentiable at x equal to x minus 1 equal to 0, means x equal to 1. It is not differentiable at x equal to 1. Like this combined modulus also, the same rule we follow. It is continuous everywhere, but not differentiable at the point where x minus 1 and x minus 2 equated to 0. That is, x is 1, comma. Okay, the combined modulus we write. Next is also same type of an example. Next, this type of questions are very important. It is given differentiable at x equal to 1. When a function is differentiable, it is continuous also at x equal to 1. So we have to apply both in the same question. So the first part is f of x is differentiable at x equal to 1. It is a previous board question. Yes, can you see this one? Are you able to see? Okay, so the first step is, since f of x is differentiable at x equal to 1, left-hand derivative at x equal to 1 is equal to right-hand derivative at x equal to 1. This is the definition of differentiability. Now, left-hand derivative means limit h tends to 0, f of a minus h minus f of a by minus h. That's the formula for left-hand derivative. So here in place of a, it is 1. So limit h tends to 0, f of 1 plus h minus f of 1 upon minus h. Then we have to substitute this in the left-hand side function. Left-hand side function is, I have written it in the rougher space. F of x is x square plus 3x plus a. Then we substitute 1 minus h. F of 1 minus h is 1 minus h the whole square plus 3 into 1 minus h plus a. And f of 1 is 1 square plus 3 into 1 plus a. Like this, in the left-hand side, we substitute, and we have to simplify it, and we get h square minus 5h. So limit h tends to 0, h square minus 5h by minus h, then h is taken outside and cancelled out, and we get minus 5 by minus 1, it is 5. This is the left-hand derivative. All of you understood this left-hand derivative calculation? Limit h tends to 0, f of a minus h minus f of a by minus h is the formula for left-hand derivative. The same way, right-hand derivative, when the function is differentiable, left-hand derivative will be equal to the right-hand derivative. So look at right-hand derivative, limit h tends to 0, f of a plus h minus f of a by h is the formula for right-hand derivative. So that comes like this, f of 1 plus h minus f of 1 divided by h. So f of 1 plus h is b into 1 plus h plus 2 minus of b into 1 plus 2 by h. So when we open the bracket, b plus bh plus 2 minus b minus 2, So we can cut these terms, b minus b and 2 minus 2, and we get bh by h. bh by h is b. So this is the right-hand derivative, bh by h, that is b. Is it clear? Then we equate these two. Left-hand derivative is equal to right-hand derivative. Left-hand derivative is equal to right-hand derivative. So we get b is equal to 5. b is equal to 5. But this is not enough to calculate a. To calculate a, we use the condition of continuity. Since f of x is differentiable at x equal to 1, it is continuous also at x equal to 1. Continuous means LHL equal to RHL equal to f of 1. Then I got LHL, that is limit x tends to 1 minus f of x, is limit x tends to 1 minus x square plus 3x plus a, or 1 square plus 3 into 1 plus a is 4 plus a. Then RHL, limit x tends to 1 minus first, so next 1 plus f of x, that is b plus 2. Then we have to equate these two, you will get a. Okay, so this is the method of calculating a and b if differentiable, if it is given. Differentiable functions are continuous. Next is also similar type. Just go through it. It is a similar type. Yes, hope you all understood this one. This is also similar type. Differentiability, when it comes, we will apply the rule of continuity as well. Like this modulus x minus 3 cos x is not differentiable at x equal to 3. So r minus is set to 3. It is continuous but not differentiable. Now, this type of question, modulus x minus 2, we know it is not differentiable at x equal to 2. So that proof may come in the examination as 3 marker or 5 marker. Through that, the function modulus x minus 2 is continuous. So the first is checking continuity. For continuity, we have to break that modulus function into two parts. Modulus x is negative and positive. So that is the definition. So modulus of x minus 2 is negative of x minus 2 if x minus 2 is less than 0 or x is less than 2, and positive x minus 2 if x minus 2 is greater than or equal to 0 or x is greater than or equal to 2. Then case 1, x belongs to minus infinity to 2. On the left of 2, all the three cases we have to check for continuity, not only at x equal to 2. So on the left of 2, f of x is negative of x minus 2. It is a polynomial function. Polynomial functions are continuous. If it is a single function like this, it is continuous for all x belongs to minus infinity to 2. Then at x equal to 2, at x equal to 2, we have to check the left-hand limit and right-hand limit. To the left of 2 and right of 2, left-hand limit is 0, right-hand limit is also 0, and f of 2 is 0. So f of x is continuous at x equal to 2. Then to the right of 2, like this everywhere, if it is continuous only, we can write it as a continuous function. So on the right of 2, like this 2 to infinity, it is a polynomial function because f of x is x minus 2. It is continuous. Since all the three cases it is continuous, we can write it is continuous for all x belongs to capital R. Is that clear, that first part? Then second part is to prove that it is not differentiable at x equal to 2. When you check differentiability, don't break the modulus into negative and positive. Inside that same modulus function itself, we can substitute the 2 minus h and all. So this is the left-hand derivative. For checking differentiability, you will find left-hand derivative and right-hand derivative. Left-hand derivative is limit h tends to 0, f of a minus h minus f of a by minus h. So f of 2 minus h minus f of 2 by minus h. and that we found modulus of 2 minus h minus 2 minus modulus of 2 minus 2 by minus h, and we get h minus 0 by minus h, it is negative 1. Left-hand derivative is negative 1. Right-hand derivative, f of 2 plus h minus f of 2 by h. So that one modulus of 2 plus h minus 2 minus of 2 minus 2 by h. So that is positive 1. Left-hand derivative is not equal to right-hand derivative. Therefore, it is not differentiable at x equal to 2. So this is the method of doing. So hope you all understood this. This type of questions are also important for 3 marker. If there is any doubt, you can ask. After this, I move to the derivative questions. So till here it is continuity and differentiability. Then the second part of that chapter, derivatives. Yes, any doubt, children, in continuity and differentiability part?
No, sir.
Now, the next is derivatives question. Derivative main questions are there in the standard results are like this. All the standard results everyone should revise and study well. Especially derivative of x raised to n is n into x raised to n minus 1. d by dx of x is 1, x squared 2x, root x is 1 by 2 root x. Next also very important, 1 by x raised to n minus n by x raised to n plus 1. Derivative of 1 by x raised to n. Derivative of constant is 0. E raised to x is e raised to x log x 1 by x. A raised to x derivative is a raised to x into log a. And the sin x is cos x is minus sin x, tan x is sec square x. Cot x is minus cosec square x, sec x is sec x into tan x. And cosec x is minus cosec x into cot x. Sin inverse x is 1 by root of 1 minus x square. Cos inverse x is minus 1 by root of 1 minus x square. Tan inverse x is 1 by 1 plus x square. Cot inverse x negative 1 by 1 plus x square. Sec inverse x 1 by x into root of x square minus 1. And cosec inverse x minus 1 by x into root of x square minus 1. So these are the basic theorems, okay, of the standard results of derivatives. Then quotient rule, chain rule. Chain rule means inside if there is a function. First of all, for example, cos, and inside there is x squared. We take the derivative of cos, it is minus sign, then multiply this with the derivative of x squared. In integral, we divide by the derivative of the function, linear function, but here we have to multiply. And this is an important question of chain rule. Y is log tan pi by 4 plus x by 2. Prove that dy by dx is sec x. So dy by dx is derivative of log is 1 by tan. So 1 by tan pi by 4 plus x by 2 into derivative of tan is sec square. So sec square pi by 4 plus x by 2 into d by dx of pi by 4 plus x by 2, that is 1 by 2. Then the denominator is of the form 2 sin a cos a. 2 sin a cos a is sin 2a. So sin 2 into pi by 4 plus x by 2. So sin pi by 2 plus x. So that is cos x. So then we get sec x. So this is an important question of chain rule. Hope you all understood this. If degree measure, if it is there, we convert it into radian measure into pi by 180. And then we have to take the derivative accordingly, okay? Then implicit function. Implicit function means x and y will be mixed up. So we have to do the differentiation throughout with respect to x. Derivative of x with respect to x is 1. But derivative of y with respect to x is dy by dx. Then we should collect the dy by dx terms together and find out dy by dx. This type of direct questions, all you have to go through. If any doubt, you can ask. Root of combined question, like this root of plus root of combined question, if you get one first term we have to leave, and then the remaining terms are up to infinity. So we will replace that with a y, because it is the same question from infinite terms. If you remove one term, it will not affect the number of terms. So that yellow shaded part is the same question only. So we rewrite the question like this: y is root of tan x plus y, and then we do the squaring on both sides. Y square is tan x plus y. Then after that, to differentiate with respect to x. Derivative of y square is 2y into dy by dx is derivative of tan x is sec square x plus dy by dx. Then dy by dx should be taken to the left side, and we have to find out dy by dx from there. That root of combined question, is it clear?
Sir, on the left side, how did we get 2y dy by dx?
Derivative of y square is 2y. Then by chain rule, derivative of y with respect to x, it is dy by dx.
Oh, okay, sir.
Is it clear?
Yes, sir, sir.
Okay. Next is very important pattern. So that pattern is some answers will be given. For example, in the right hand side, I have written dy by dx is sine square a plus y by a. So the right hand side of the required answer is only in terms of y. There is only y in the right hand side. So if the right hand side is in terms of y, we have to write the given expression in the form x equal to f of y. This pattern of questions are very important. X equal to f of y. Then we should differentiate with respect to y and get dx by dy. Then take the reciprocal to find dy by dx. So this pattern of question you have to practice again and again. On the other way around, if the right hand side of the required answer is in terms of x, fully in terms of x, then we should rewrite the given question in the form y is equal to f of x. Then differentiate it with respect to x, and directly we can find dy by dx. So this is a typical question. It is there in past papers also. If sine y is equal to x sine a plus y, look at the answer. Here, based on the answer, we discuss the method, we decide the method of doing. Dy by dx, prove that dy by dx is equal to sine square a plus y upon sine a. Here, the right hand side, that yellow shaded region, is fully in terms of y. So when it is fully in terms of y, when the answer is fully in terms of y, we have to rewrite the question first of all like this: x in terms of y, x equal to f of y. So that is the first step. Writing x as sine y by sine a plus y. Then differentiate with respect to y. Dx by dy is by quotient rule. That differentiation I have done. Quotient rule everybody knows. So the first step, is it clear? Writing x on one side and right hand side, the complete y terms we move to the right hand side, x equal to f of y form. Is it clear, children? That the first step. Then quotient rule I applied. Denominator into sine a plus y into derivative of sine y, derivative of numerator, it is cos y, minus numerator, that is sine y, into derivative of denominator. Derivative of sine a plus y is cos a plus y whole divided by square of the denominator. It is sine square a plus y. Now the numerator is of the form sine a cos b minus cos a sine b. That is sine a minus b. Sine a cos b minus cos a sine b form. It is sine a minus b. So we get sine a plus y minus y, that is sine a, or sine a by sine square a plus y. Then we have to take the reciprocal on both sides to get dy by dx. So dy by dx is sine square a plus y by sine a. Hope you all understood this. It is a very important 2-marker or 3-marker type. Next question is also similar type. Writing x in terms of y, x equal to f of y. because right-hand side is in terms of y, and then differentiate with respect to y, and finally we take the reciprocal. Next question, in the answer, right-hand side is in terms of x. Right-hand side is minus 1 by 1 plus x the whole square. This type of questions we have to write y in terms of x. Y is equal to f of x form. For that, I have copied that given expression. Then I took the second term to the right side. X of x into root of 1 plus y is minus y into root of 1 plus x. Second term, I have taken that one to the right side. Then squaring on both sides. X square into 1 plus y is y square into 1 plus x. Then we have opened the bracket and took y square to the left side. Then factorization is done. Then right-hand side minus xy into x minus y. So that x minus y we can cut. Then I took the terms of y to the left side because we have to express it in the form y in terms of x. Y is equal to f of x. Or y plus xy is equal to minus x. Or y into 1 plus x is minus x, or y is equal to minus x by 1 plus x. Y is equal to minus x by 1 plus x. We got y in terms of x. Is it clear? After that, differentiate
Yes,
with
sir.
respect by quotient rule, the derivative, denominator into derivative of the numerator, minus numerator into derivative of the denominator by square of the denominator. Okay, so this way we can easily do the derivative. So this question is also an important question. Here all we can see the right-hand sides of the question. Based on that, we decide writing x equal to f of y or y is equal to f of x. Here right-hand side is fully x. That is the reason what we wrote y equal to f of x form. So this type of questions you have to practice again and again until you get the clear idea. Okay. Then trigonometry substitution, that is normally an easy topic. 2x by 1 plus x square, x is tan theta is enough. So 2 tan theta by 1 plus tan square sine 2 theta we get, then we can cancel out. And here, this is also direct question, x is sine theta is enough. But different types of questions are there. Derivative of a function with respect to other means, we take one of them as u and find du by dx. And second, we write v and find dv by dx. Then u with respect to v means we have to get du by dv. Du by dv is du by dx by dv by dx. That is a method of doing a function with respect to another, u with respect to v. So du by dv is du by dx by dv by dx. Here also some variety questions are there. For example, this one, 1 plus x square and 1 minus x square, both together. Recently in integral also we discussed that. If it comes there in a question, we put x square equal to cos 2 theta, because 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sine square theta. Okay. Then we get this form. 1 minus tan theta by 1 plus tan theta is tan pi by 4 minus theta. Then we can do the simplification. Then here the variety questions. So this is an important question. Here 1 minus x square and 1 minus y square. Here we take x as sine A and y as sine B. Then it is 1 minus sine square A. The other one, root of 1 minus sine square B. 1 minus sine square A is cos square A. Root of cos square A is cos A. So cos A plus cos B is equal to A into sine A minus sine B. Now cos A plus cos B, we apply the rule. 2 cos A plus B by 2, the sum formula, into cos A minus B by 2. Sine A minus sine B, 2 cos A plus B by 2 into sine A minus B by 2. Then we get cos by sine form cot. And then A minus B like this. Then we substitute A and B and differentiate with respect to x. Okay, so this type also you have to practice well. Even this question also the same rule, x cube is sine A and y cube is sine B. Then we get the same pattern, okay, even in this question. Another important trigonometry substitution is this one. It is a question which is solved in the textbook. Here we have to split 2 raised to x plus 1 like this. 2 raised to x into 2 raised to 1. And denominator 4 raised to x is 2 raised to x the whole square. Then we put 2 raised to x as tan theta. Very, very important substitution. Put 2 raised to x equal to tan theta, or theta is tan inverse 2 raised to x. Then it is of the form 2 tan theta by 1 plus tan square theta. Okay, 2 tan theta by 1 plus tan square theta is sine 2 theta. So it comes like the sine inverse sine 2 theta. So that is 2 theta, or it is 2 tan inverse 2 raised to x. 2 theta means 2 times tan inverse 2 raised to x. And then we have to do the derivative. dy by dx is 2 into derivative of tan inverse 2 raised to x is 1 by 1 plus x square form. 1 by 1 plus 2 raised to x the whole square into d by dx of 2 raised to x. Okay, so d by dx of 2 raised to x is 2 raised to x log 2. And we multiply 2 and 2 raised to x. That is 2 raised to x plus 1 log 2 by 1 plus 4 raised to x. And that is the final answer. Okay, so this is a solved example and practice it well. Next is also a similar type. Here 2 raised to x plus 1 we split like this, 2 raised to x into 2 raised to 1. And 36 we write 6 square the whole raised to x, or 6 raised to x the whole square. Then we put 6 raised to x equal to tan theta, or theta is tan inverse 6 raised to x. Then we get sine inverse sine 2 theta, or 2 theta, that is 2 times tan inverse 6 raised to x. Okay, so then we find dy by dx from there. Okay, even this question is another important trigonometry substitution. Here the question is, if y is equal to sine inverse 5x plus 12 into root of 1 minus x square whole divided by 13. Here, first of all, we have to break like this: 5 by 13 into x plus 12 by 13 into root of 1 minus x square. Then we are going to get this in the form. I have written that formula in the refer space. Sine A cos B plus cos A sine B. For that, we have to take, let 5 by 13 is equal to sine A. Like opposite by hypotenuse. Opposite side is 5 and hypotenuse is 13. We found the adjacent side as 12 by Pythagorean triplet. Adjacent side will be 12. Then cos A is 12 by 13. So we can see cos A is there in the second term. So that will become 12 by 13. Same way, we have to take x equal to cos B, because we have to get the form sine A cos B plus. So I took x is cos B. Then sine B is root of 1 minus cos square B by class 10 identity. That is root of 1 minus x square. So the second term is cos sine B. Then we substitute this to the question. It is of the form sine inverse sine A cos B plus cos A sine B. That is sine inverse sine A plus B. Sine inverse sine will go, or we get A plus B and substitute for A and B. Since sine A is 5 by 13, A is sine inverse 5 by 13, cos B is x, so B is cos inverse x. Then when you do the derivative of sine inverse 5 by 13 is 0. Derivative of cos inverse x is minus 1 by root of 1 minus x square. This is the complete answer to this question. Is it clear, children, this particular one? It is also an important 3-marker question. All of you got it clear?
Yes, sir.
Then very important, another topic, logarithmic differentiation. So we apply the log rules here. If n is a raised to x, log n to the base a is x. And log e is 1. Log a into b is log a plus log b. Log a by b is log a minus log b. Log a raised to r is r log a. And e raised to log f of x is f of x. Base changing rule, we don't apply that much. This type of a function raised to another function, x raised to x, x raised to sine x. If base and exponents are functions of x, we apply logarithmic differentiation. So please see this question. So first we write let y is equal to x raised to x. Then we have to take the log on both sides. Log y is equal to log x raised to x. This is the starting of all logarithmic differentiation question. We can easily identify the question because a function raised to another function. So right hand side is log a raised to r, that is r log a form. So that is x log x. Then differentiate with respect to x. Left hand side is 1 by y into dy by dx equal to, right hand side is product form, x into derivative of log x. Derivative of log x is 1 by x plus log x into 1. So that is 1 plus log x. We have to take y to the right side. Y is x raised to x. So x raised to x into 1 plus log x. This is dy by dx. X raised to x into 1 plus log x. Is that clear? The same pattern, all the direct questions we do, apply it, write the question as y, and then taking log on both sides. Right hand side is log a raised to r log a. Then product rule will be applied in the right hand side, and then we simplify it like this. Is it clear? All of you got it clear, children?
Yes, sir.
This type of combined questions can be asked, like x raised to log x plus log x raised to x. So that one we have to write y is equal to u plus v. Then differentiate with respect to x. dy by dx is du by dx plus dv by dx. So then we take the first one as u is equal to x raised to log x. Then the same way, taking log on both sides, and we have to find du by dx. Then second one is v. So from there we find dv by dx. Then we will add these two. This is the method of doing combined questions. Y is u plus v. dy by dx is du by dx plus dv by dx. Here inside combined question, this type of product also can be asked. So here u is x sin x the whole raised to 1 by x, and v is x cos x the whole raised to x. Here you have to check when you do du by dx. Log u is 1 by x into log x sin x. Then I applied the product rule. 1 by u into du by dx, right hand side, 1 by x into derivative of the second. Derivative of log x sin x is 1 by x sin x into d by dx of x sin x plus log x sin x into derivative of 1 by x, that is minus 1 by x square. Now this is important, that yellow highlighted part. Derivative of x sin x, again we do by product rule. X into derivative of sin x, that is cos x plus sin x into 1. Like that, that yellow highlighted point is very, very important. Product rule should be applied there. And then we open the bracket, and then we get a du by dx from there. U is taken to the right side. Same way, dv by dx, there also, this part, we applied that product rule for x cos x. Product rule is applied here. Is it okay? All of you got it clear?
Yes, sir.
Yes. Next, this type of combined question also we take x raised to y to 1. Then differentiate, we get du by dx plus dv by dx equal to 0, equation number 1. Then we find du by dx and dv by dx and substitute to this, and from there you will find dy by dx. Remaining part is same normal logarithmic differentiation. We get like this u, and taking log on both sides, you will get du by dx, and from v, taking log on both sides, we get dv by dx, and then we substitute in that expression du by dx plus dv by dx equal to 0, and from there we get dy by dx. Another important pattern is this one. Find dy by dx if y raised to x equal to x raised to y. Here also we have to take x is log x raised to y. Like this equality equating two expressions also, we take log on both sides if it is a variable raised to another variable. Then x log y is y log x. Left hand side is done by product rule. X into derivative of log y, that is 1 by y into dy by dx plus log y into 1 equal to right hand side by product rule y into 1 by x plus log x into dy by dx. Then that dy by dx must be taken to the left side. Take a common factor dy by dx. The remaining terms to the right side, and from there we have to find dy by dx. Is that clear, that pattern? X raised to y is equal to y raised to x. Applying log on both sides. All of you understood this? Even this question is also the same type. Cos x the whole raised to y is cos y the whole raised to x. We have to take log on both sides and then you will get the answer. And this is another important question. Xy is e raised to x minus y. So here also we apply log on both sides. Log xy is log e raised to x minus y. That is x minus y log e, but log e is 1. Log e, don't forget, log e is 1. Then differentiate with respect to x. And then finally, we get the answer like this. But the same type of a question is there. Answer, look at the answer, prove that question. But the right-hand side in terms of x, log x by 1 plus log x the whole square. So it is a combined question of logarithmic and implicit form. So when the right-hand side is in terms of x, we have to rewrite the question in the form y is equal to f of x. So that is our first task. We apply log on both sides and break it using log. And we have to write like this, y is equal to x by 1 plus log x. This pattern is also very, very important. 3 marker or 5 marker. Is it clear, children, that first few steps? And the importance of writing that y is in terms of x, because an answer is given. In that answer, right hand side, there is only x. So we wrote y is equal to x by 1 plus log x, then dy by dx by quotient rule. 1 plus log x into 1 plus x into 1 by x plus denominator square by denominator square, and then you will be getting the answer, okay? So most of the important logarithmic differentiation I explained. Is it clear? All of you understood?
Yes, sir.
Yes.
Next is parametric forms. Parametric forms means this is also logarithmic, but taking log on both sides, you will get. Here left hand side is log a plus log a v form, the normal derivative, and you will get this. This type of questions also don't leave and practice well, okay? Next, parametric forms. In this question, right hand side is in terms of y. When it is y, we have to write x is equal to f of y form, okay? Like this, all the questions in the past from the past papers we have done. Parametric form means x will be given in terms of a parameter t, and y also, like t or theta will be given. Our first task is find dx by dt, and then we have to find dy by dt. Then dy by dx is dy by dt upon dx by dt. After studying the second derivative, we have done parametric forms of second derivative. That is also more important. This is first derivative. For example, x is t cube. Dx by dt is 3t square. Y is t square. Dy by dt is 2t. Then we have divided these two. Dy by dx is dy by dt by dx by dt. So it is 2 by 3t. Okay, so this pattern of questions also you have to study well. It is not so tough. Here x and y are given in terms of theta. First step, dx by d theta. So a into 0 minus sine theta, that is a sine theta. Y is a into theta plus sine theta, that is a into 1 plus cos theta. Then we have divided these two. And after that, simplification also can be done here. 2 cos square theta by 2 by 2 sin theta by 2 by cos theta by 2. Answer is cot theta by 2. Is it clear? Sin 2a is 2 sin a cos a. This is another important question. Here all second derivative also must be studied. Immediately after this, I will explain the second derivative of parametric forms along with this. So x is a into cos t plus log tan t by 2. Here dx by dt is a into derivative of cos t is minus sin t plus log tan t by 2. 1 by tan t by 2 into derivative of tan. That is sec square t by 2 into 1 by 2. So we get a into minus sin t plus 1 by sin t by 2 by cos t by 2 into 1 by cos square t by 2 into 1 by 2. And that when you simplify, we get 1 by 2 sin t by 2 into cos t by 2. That is of the form 2 sin a cos a sin 2a. So minus sin t plus 1 by sin t. So we got the answer like this: 1 minus sin square t by sin t, or a cos square t by sin t. This is a dx by dt. After that, y is a sin t. We get dy by dt. Then we divide these two to get dy by dx. That question, is it clear? Especially the first part. All of you understood? Now see the second derivative of parametric. Immediately after this, I just go through that one. Second derivative of parametric. Second derivative, towards the end, I explain that type. This one. Second order derivative of parametric forms. That is, find d square y by dx. Okay. So are you all there, children? Or
Yes.
did you sleep? Are you there?
Yes.
Yes, sir.
Nathaniel responding. What about Johan, Tariq,
Yes, sir. Yes, sir.
Arjun? All are there, right? Nandana,
Yes, sir.
Janjit, all are there. Okay, fine. Okay, fine. Remaining students told they are okay with this chapter. That is what I did not compel anyone. Those who have doubt, only ask, or those who want to learn this one more round. That is what I did not compel any student. Okay, so x is 8t square. Dx by dt is a into 2t. So that is 2at. First derivative we find first. Parametric forms second derivative also. First of all, we have to find out the first derivative. Then dy by dt is 2a into 1. That is 2a. Then dy by dx is dy by dt upon dx by dt. So we get 2a by 2at is 1 by t. First derivative is fine, right? Then the second derivative, that part everyone should listen to and practice well. D by dx of dy by dx. D square y by dx square means d by dx of dy by dx. which means d by dx of 1 by t, d by dx of 1 by t. Then we take the derivative of 1 by t. Derivative of 1 by t is minus 1 by t square into derivative of t with respect to x, that is dt by dx, minus 1 by t square into dt by dx. Then dt by dx we find by taking the reciprocal of dx by dt. So it is actually a chain rule with respect to x, and inside the variable is t. That is what? Derivative of 1 by t is done, minus 1 by t square into derivative of t with respect to x, dt by dx. Look at their refer space. dt by dx is reciprocal of dx by dt, 1 by 2at here, and then we multiply and we get minus 1 by 2at cube. Is it clear that second derivative concept of parametric form? That into dt by dx. This is a highlight of the second derivative. Into dt by dx will be there. Even this question is also the same. Already explained the first derivative, dx by dt like this, and we get a cos dy by dx is tan t. Then look at there, d square y by dx square is d by dx of tan t. Derivative of tan t is sec square t into derivative of t with respect to x, dt by dx. Okay, so the dt by dx is reciprocal of dx by dt sin t by a cos square t, and we will get the answer like this. All of you understood this concept? Clear, right? Yes. Even this question is also same pattern. First dx by dt, but t sin t, product rule is applied. T into derivative of sin t plus sin t into 1. Like that we got dx by dt as 8t cos t. Then dy by dt we got. Then dy by dx. dy by dt upon dx by dt. That we got tan t. Then second derivative. D by dx of tan t means sec square t into here also dt by dx. Okay, so the dt by dx is reciprocal of dx by dt. So everybody got the clear idea of second derivative? Clear, right? Nathaniel, Tariq,
Yes, sir.
Ranjit, all of you got it clear, right?
Yes, sir. Yes, sir.
Second derivative. Okay.
Yes, sir.
Then second derivative proofs are there. That one before this I explained. From there also we expect 3 marker or 5 marker question. This type of proofs are there based on second derivative. We quickly go through that. That is the last part of derivatives. Like this derivative is an easy topic. Okay. Like this from your part also, 2 or 3 rounds you have to revise. If y is equal to f of x, it is a function of x, then dy by dx is first order derivative, d square y by dx, or it can also be denoted by y dash for dy by dx, y double dash for second derivative, y1 and y2, f dash x and f double dash x. Some questions from the derivation itself we get the answer. Some questions we need to substitute in the left hand side. For example, this question, when we derive itself, we get y is a sin x plus b cos x. dy by dx is a into derivative of sin x is cos x plus b into derivative of cos x is minus sin x. That is a cos x minus b sin x. Then second derivative d square y by dx square a into minus sin x minus b into cos x. That is minus of a sin x plus b cos x, and that we got minus y. Then we have to bring minus y to the left side. So d square y by dx square plus y is equal to 0 is the answer. D square y by dx square plus y is equal to 0. Clear? This is a pattern of most of the questions. In this question, we find dy by dx. That is chain rule is also applied. 3 e raised to 2x into 2 plus 2 e raised to 3x into 3. Then from the second derivative, But here we did not get from the derivation. So we have to substitute this in the left-hand side. That yellow highlighted part is the left-hand side that we copied and to get the answer. This is an important 3-marker question. Why is sine inverse x? Show that 1 minus x square into d square y by dx square minus x dy by dx equal to 0. So first of all, we find dy by dx, that is 1 by root of 1 minus x square. When we do the cross multiplication, we get root of 1 minus x square into dy by dx equal to 1. Then differentiate with respect to x. So that comes root of 1 minus x square into derivative of dy by dx is d square y by dx square plus dy by dx into derivative of root of 1 minus x square is 1 by 2 root of 1 minus x square into minus 2x. Then the 2 will go. Root of 1 minus x square is multiplied to the first term. So we got 1 minus x square into d square y by dx square minus x dy by dx equal to 0. Like this, from the that part itself, we can get the final answer for some question. Next is y is equal to 3 cos log x plus 4 sin log x. So is d square y by dx square. First, y1 is simplified. Y is 3 cos log x plus 4 sin log x. Y1 is 3 into derivative of cos is minus sin log x into 1 by x plus 4 into derivative of sin is cos log x into 1 by x. After that, 1 by x is taken outside. Then that x is multiplied to the left. X y1 we got. Then again, differentiate with respect to x. Left-hand side by the product rule. X into derivative of y1 means y2 plus y1 into 1 is equal to minus 3 into derivative of sin log x is cos log x into derivative of log x, that is 1 by x plus 4 into derivative of cos log x is minus sin log x into 1 by x. Then that minus 1 by x is taken outside and then x is multiplied to the left. We open the bracket to get the answer. X square y2 plus x y1 plus y equal to 0. Are you all okay with these questions, right? Okay, so next is the same pattern I explained already. This is also a similar pattern. And this one, we have to take the derivative and take it to one side and get this question. Y is equal to tan inverse x the whole square. First, y1. Y1 means first derivative. Similar to x square, 2x. So 2 into tan inverse x into d by dx of tan inverse x. That is 1 by 1 plus x square. Then that 1 plus x square is multiplied to the left side. X square plus 1 into y1 is 2 tan inverse x. Then differentiate with respect to x. X square plus 1 into derivative of y1 is y2 plus y1 into 2x equal to 2 into 1 by 1 plus x square. Then that 1 plus x square is multiplied to the left side to get the answer. Clear? Next is one of the lengthy questions, an important question also of second derivative. If a plus bx into e raised to y by x equal to x, then prove that x cube d square y by dx square is equal to x dy by dx minus y the whole square. First step, taking log on both sides. That is log of a plus bx into e raised to y by x equal to log x, because it is variable raised to variable form, and product, to break the product, we apply log. Then log a into b is log a plus log b. So left hand side is log a plus bx plus log e raised to y by x. Second term is log a raised to r form, r log a, that is y by x log e. Second term is r log a, y by x log e. Log e is 1. Then I took that log a plus bx, long terms to the right side. Y by x is log x minus log a plus bx. Then differentiate with respect to x, left hand side by quotient rule. denominator x into derivative of y with respect to x is dy by dx minus y into 1 whole divided by square of x square equal to right hand side derivative of log x is 1 by x minus derivative of log a plus bx is 1 by a plus bx into b. 1 by a plus bx into b. Then we have taken the LCM of on the right side, a plus bx minus bx by x into a plus bx. We got a by x into a plus bx. That x is cancelled on both sides, and we got, and then we have multiplied that x to the right side numerator. X dy by dx minus y is ax by a plus bx. That we put as equation number 1. Is that clear? That quotient rule and the right hand side derivative and all. Then we have to do one more round of derivative. First term is by product rule x dy by dx. That is x into derivative of dy by dx is d square y by dx square plus dy by dx into 1 minus dy by dx is right hand side again by quotient rule. Denominator, that is a plus bx into a minus ax into b all divided by the square, a plus bx the whole square. Then abx minus abx will go a square by a plus bx the whole square. Then multiply both the side by x square. We have to multiply both the sides by x square. Left hand side is x cube d square y by dx square is a square x square by a plus bx the whole square. That is ax by a plus bx the whole square. Now ax by a plus bx we substitute from equation number 1. Because our answer left hand side is x cube d square y by dx. So that is the reason what we multiply by x square. Then we get the final answer x dy by dx minus y the whole square. All of you understood this? This question is there in past papers. So these are some very important questions of second order derivative derivations. This type of other derivations also you have to practice well. Next, a quick review of applications of derivatives, especially the increasing and decreasing functions question. Increasing and decreasing functions questions of applications of derivative. So there will be questions to find out the intervals in which the function is increasing or decreasing. Or first derivative test also we apply that same rule of increasing and decreasing functions. Okay, so this type of questions are very important. Finding intervals if a function is increasing or decreasing. So this is a cubic polynomial. Cubic polynomial or fourth degree polynomial also can be asked. Find the interval in which the function f of x equal to 4x cube minus 6x square minus 72x plus 30 is number 1 strictly increasing and number 2 strictly decreasing. First of all, we find f dash x. That is 4 into derivative of x cube is 3x square minus 6 into 2x minus 72 into 1. So that we get 12x square minus 12x minus 72. Then 12 is taken outside. In every question of finding intervals, first of all, we have to find out f dash x. Then we equate it to 0. Polynomials we can factorize. So when we factorize x square minus x minus 6, sum is -1 and product is -6. So we get -3 and 2. It is x minus 3 into x plus 2, 0. So x is 3 and x is -2. For cubic, derivative will be quadratic, and we get two solutions, two roots for the quadratic equations. Then we have to draw the number line, and we will mark these points in increasing order. -2 first, then 3. On the left of -2, minus infinity, and on the right of 3, infinity. So we break the intervals like this, minus and 3 to infinity. So then we write the intervals like this, minus infinity to -2, then -2 to 3, and then 3 to infinity. So f dash x is 12 into x minus 3 into x plus 2. So 12, x minus 3, and x plus 2 are the three important intervals here. So then we write 12 is positive, x minus 3 is negative, x plus 2 is negative, x plus 2 is negative. Okay, so then we will take this one, f dash x. So why that x minus 3 negative, all of you understood. In the interval minus infinity to -2, we have to take a value in between minus infinity and -2. I took -4. -4, if I substitute for x minus 3, -4 minus 3 is negative. That's the method of finding the sign of that factors. In x plus 2 also, I substituted -4 because -4 is, so that comes negative. Then the sign of f dash x is a product of these three. Plus into first line, plus into minus, it is positive. That is what it is written. F dash x is greater than 0, or it is strictly increasing. Is it clear, children?
Yes, sir.
Same way, -2 to 3, I took a value 1 in that interval. 12 is positive. So 1, when I substitute for x minus 3, 1 minus 3 is negative. And 1 plus 2, for x plus 2, it is positive. The product of these three is negative. That is what f dash x is less than 0. Strictly decreasing. Strictly decreasing. Third line is also done the same way. Third, I took the value 4. 3 to infinity, I took 4. Then 4 minus 3 is positive. 4 plus 2 is positive. Altogether, it is positive. So strictly increasing. Then we write the conclusion like this. Strictly increasing in two intervals means we combine them by union, and strictly decreasing in the other one, -2 to 3. All of you understood? Is that clear, children?
Yes, sir.
And here, from here, first derivative test can be asked. First derivative test, it is the continuation of these steps. That means if first derivative test is asked, you will write all these steps. Then from there, we have to draw a nature of diagram like this. Minus infinity to -2 increasing. You can see the diagram going up. Then -2 to 3 going down, decreasing. So -2 to 3, the function goes down, decreasing. Then 3 to infinity, it is increasing. That means -2 is on top. That is, it is a point of local maximum. And 3 is a point of local minimum. Then if they ask us to find out the absolute maximum, we substitute this -2 in the main function f of x and 3 in the main function f of x. We'll get the local maximum value and local minimum value. Here there is only one of them, so that will be the absolute maximum and absolute minimum. This means first derivative test of finding local maximum and local minimum, the same steps must be written, and then we have to draw a diagram like this. Then we find the points and substitute that point in the function. That type of questions also you have to go through. At the end, I have explained the typical that type of question. These are all similar. Cubic, we get quadratic. And there is a fourth degree question. Here. This is a solved example in the miscellaneous part. very important. F of x is 3 by 10 x raised to 4 minus 4 by 5 x cube minus 3x square plus 36 by strictly decreasing. We found f dash x. F dash x, you can see the calculation. 6 by 5 is taken outside after taking the LCM. Then that cubic polynomial factorization is done. Class 9 method, trial and error method. So f of 1, when we checked, it is 0. So x minus 1 is a factor of f of x. Then x minus 1 is divided there. So we got the quadratic polynomial over there, quadratic. So you can see the long division process. Long division is done. We got quadratic. Then equated that quadratic polynomial like this. And then we have factorized the quadratic. So this is a method of finding cubic polynomial. And then we get 3 values for x, because x minus 1, x minus 3, x plus 2 are factors. X is 1, 3, and minus 2. 1, 3, and minus 2. Then we have to draw the number line and break like this. Like this fourth degree polynomial, when we do the derivative, we get cubic. And then we find the 4 intervals. 4 intervals we get in this type of question. Then we write the same type of column. Here the factors of f dash x, 6 by 5, x minus 1, x minus 3, and x plus 2. Their product is f dash x. And f dash x greater than 0 and f dash x less than 0, we get like this, okay? So I will scroll it up. If any part, if it is a doubt, you can ask and clear the doubt. That division, long division, that class 9 method is done. All of you got it clear? Nathaniel? These are the polynomial type of question. The same way, trigonometry type of questions are also there. Trigonometry types are also important. Trigonometry or polynomial, one of the questions we expect this type for finding the intervals in which the function is increasing or decreasing. Yes, done. Next, trigonometry type, polynomial, similar type, only how to practice well all the possible questions we have done. This is a trigonometry type question. Trigonometry type, it is not from minus infinity to infinity. It will be either from 0 to pi by 2 or from 0 to 2 pi. So accordingly, we write the interval. Here f of x is sine 3x. Here also we do the same pattern, f dash x. Cos 3x into 3, that is 3 cos 3x. Then f dash x equated to 0. Cos 3x is 0. Or 3x is pi by 2, x is pi by 6. Then we could break the intervals like the 0 to pi by 6 and pi by 6 to pi by 2. Then in f dash x, we substituted 0 to pi by 6. I substituted 0. 0 is included there in that interval, because at 0, f dash x is not 0. So we could take 0. Both are positive. And pi by 6 to pi by 2, I substituted 60 degree, pi by 3. Cos 3 into 60, cos 180 is negative. So that is negative. In that case, f dash x is less than 0. So we could write this is sin x plus cos x. Here it is from 0 to 2 pi, 0 to 2 pi. So there, that quadrant rules also we have to note down when it is from 0 to 2 pi. First step is f dash x. Derivative of sin x is cos x. And derivative of cos x is minus sin x. Then f dash x equated to 0. Or cos x minus sin x is 0. We get cos x equal to sin x. Or 1 is equal to sin x by cos x. Or tan x is 1. And next, very, very important, I have written that in the reference space. Tan x is 1. in first quadrant and third quadrant. Tan is positive in first quadrant and the third quadrant. So tan x is 1 when x is 45 degrees. So the first value of x is pi by 4. Next, in third quadrant, we take the angle pi plus theta. That is pi plus pi by 4. It is 5 pi by 4. X is 5 pi by 4. Then we will break it into intervals like the 0 to pi by 4, then pi by 4 to 5 pi by 4, then 5 pi by 4 to 2 pi. Like this, we break this into 3 intervals, and then we have to get the derivatives 0 to pi by 4, then pi by 4 to 5 pi by 4, 5 pi by 4 to 2 pi. Then in f dash x, I substituted. Like this, for when it is 0 to 2 pi, normally two values we can find out, okay, by checking the quadrant in which it is negative or positive. Is it clear? And this is the rule. First quadrant, if we take theta, second quadrant, it will be pi minus theta, third pi plus theta, fourth quadrant, we take 2 pi minus theta. Like that corresponding pi theta after finding out from first quadrant, we use this rule. I will show you negative value question also. And the remaining part is simple. I substituted 0 to pi by 4, I substituted 0. And then pi by 4 to 5 pi by 4, 45 to the 225, I substituted 90 degree. It is negative. 5 pi by 4 to 2 pi, I substituted 2 pi. So that is positive. Then we write the intervals. In this question, we are getting negative value. Sin x minus root 3 cos x. So f dash x is derivative of sin x is cos x minus root 3 into derivative of cos x is minus sin x. That is cos x plus root 3 sin x. Then we equated it to 0. F dash x equal to 0. So what do you get? F dash x equal to 0. Cos x plus root 3 sin x 0 means root 3 sin x is minus cos x, or tan x equal to sin x by cos x is minus 1 by root 3. Tan x is negative. And here also the clear explanation I have written in the reference page. Tan is negative in second and fourth quadrant. And we know tan 30 is tan 30 or tan pi by 6 is 1 by root 3. Here theta is pi by 6. Here theta is pi by 6. So the second quadrant value we take like this, x equal to pi minus theta. That is pi minus pi by 6, or it is 5 pi by 6. Second quadrant value is pi minus theta, or we get 5 pi by 6. And the fourth quadrant value is 2 pi minus theta, or 2 pi minus pi by 6. That is 11 pi by. And the fourth quadrant, because tan is negative, so we take the values, angles in second and fourth quadrant. When tan is positive, it is in first and third quadrant. Second quadrant is pi minus theta. Fourth is 2 pi minus theta. That theta is the corresponding angle in the first quadrant by equating it to the positive value. All of you got it clear? Then 0 to 2 pi, we have to break this into the intervals like this. 0 to pi by 6. 0 is included there, so closed interval. Then pi by 6 and 11 pi by 6 are excluded. So 5 by 6 to 11 pi by 6, then 11 pi by 6 to 2 pi. Then we substitute these intervals in f dash x, and then we get cos 0 plus root 3 sin 0. That is 1 plus 0 is 1. Then f dash x greater than 0 or f dash x less than 0, which means strictly increasing or strictly decreasing, we can find out. In the first interval, it is strictly increasing. Second interval, 5 pi by 6 to 11 pi by 6. We substituted 180 degree. So that one is negative, which means f dash x is less than 0, strictly decreasing. Then 11 pi by 6 to 2 pi. I substituted 2 pi over there. So f dash x is greater than 0, that is strictly increasing. So strictly increasing in the union of which one? First and the third interval, and strictly decreasing in the second interval. So these types of questions all are like this, and practice it well. And this question also, the rule is applied that 2 sine A cos B, sine 2A, then we get minus sine 4x, then equated to 0, and we got 0 and pi by 4, then we have to break it into different intervals, okay? MCQ questions are there. Yes, Nathaniel, MCQs are there, increasing and decreasing. Towards the end, we have done. Lot of MCQs we have done. It is there in your notebook, right? All the different types of MCQs are there. For example, I will show some examples. We have done MCQs as MCQs. Towards the end of this chapter, we have done. I will show you some questions of MCQs. That is NCERT exemplar type of questions also there. Case study questions are there of this chapter. That also we have done. Very important case study questions of this chapter. So please refer to the notebook properly. Many questions we have done in the notebook. Maximum, minimum also, most of the derivations we have done. So I'm not going to that one, the derivations. All of you have to practice it very well. Yes, like this case study we have done. And then MCQs also there. Yes, these are some typical MCQs. If x is real, then the minimum value. So minimum value means we find first derivative f dash x equated to 0. Then second derivative test is applied. So we got x is 4. That is a critical point. F double dash x is positive. So it is minimum at x equal to 4. Then substitute that in the function. We get the minimum value. This type of simple questions can be asked. And this is another question. MCQs like that we have done towards the end. Nathaniel, is it there in the notebook? So this is another MCQ. So this is a very, very important another MCQ. F of x is x raised to x. Has a stationary point at. Stationary point means find the point where dy by dx is 0. First, y is x raised to x. Log y is log x raised to x. That is x log x. Then differentiate. Logarithmic differentiation is done here to break this. So dy by dx we got x raised to x into 1 plus log x. Then equated to 0. X raised to x cannot be 0. 1 plus log x is 0 means log x is minus 1. Log x means log x to the base e. So x is e raised to minus 1 or x is 1 by e. So this type of MCQs are also important. So practice it very well. Refer to the notebook also properly. And if there is any doubt, you can ask. Okay, so wish you all the best for your examination. Okay, thank you all.